Hello my dears. So now we are going to discuss about the concept of dielectric power loss, my dears. Dielectric power loss. So likewise in the overhead transmission line there are I square losses, because whenever there is a flow of current through the conductor there will be I square losses. So we have to consider that loss also for the performance analysis of the overhead transmission line. So similarly, while dealing with the underground transmission system, we have to consider the dielectric power loss, because where this dielectric power loss is arise, from where this dielectric power loss is arise. See, this is the conductor, my dear. This is the conductor, single core cable. I am considering for a single core cable or single phase cable. 3 core means it may be 3 phase cable, right? 3 phase cable is also 3 core cable, RYB. Okay, similarly it is a single phase cable. So here, listen my dear, this is the conductor, and the overall in the structure of the 3 core, underground cable, you already discussed in the last class. So in that you might have noticed one thing: conductor above all is nothing but is nothing but the insulation, right? The conductor above all are the insulation. Type of insulation: paper, bedding, armoring, again water, serving, like outer sheath, etc. So all are insulation. So I can conclude like this: this is overall an insulation, a single conductor, and the outside of the insulation, that is nothing but the sheath, right? Outside sheath, PVC sheath, that is what? Earthed, in order to make the potential to zero. Is it clear? Okay, clearly visible now? Yes, everything is clear now? Yes, everything is clear, correct. Okay, so so what is meant by this dielectric power loss is nothing but, my dear, there is actually a very long derivation, but for examination point of view, we don't want that derivation. We just know the equation for the dielectric power loss per phase. So power loss per phase is nothing but, my dears, V square omega C del. V square omega C del. I will explain each term, where V is nothing but V phase or phase voltage. Similarly, phase voltage simply. Omega is, this angular frequency or frequency simply. And C is nothing but the what? This capacitance, my dear. Sheath is nothing but this capacitance. And how this capacitance arise? See, this is the conductor. It is carrying a certain amount of current, right? And the outer covering, this outer covering also connected to ground. Ground contains enormous, infinite number of charges. So that is also considered to be a conductor. So two conductor separated by an insulating material. That forms a capacitor. That forms the capacitor. That capacitance C is nothing but this. So C is called insulation capacitance. Insulation capacitance. And del is nothing but, my dear, very important term, loss angle in radian. This is in radian per second. This is in radian. This is in radian. So in order to explain this loss angle, I have to make the equivalent circuit of this dielectric, the single core underground cable. The equivalent circuit, my dear, equivalent circuit is nothing but, my dear, a capacitor in parallel with a resistor. This is the equivalent circuit of the underground cable. Very, very important concept. Very, very important concept. See, in overhead transmission line, we discussed the various type of equivalent circuit, right? While considering R, L, C, conductance, G, everything we considered. So we made so many equivalent circuit now. Similarly, in the underground cable, having an equivalent circuit of simply RC parallel combination. RC parallel combination. And this is nothing but, my dear, nothing. Similarly, we can say like this: This is now V phase, and this is the total current I, and this is IC, this is IR. Okay, this is IR. And the equivalent phasor diagram also I can explain like this. Equivalent phasor diagram. This is V phase, this is IR, this is IC, this is I, and this is nothing but my phi, and this is nothing but, my dear, the loss angle. The loss angle is nothing but the angle between the resultant current and the capacitive current, that is IC. This is IC, is called the what? Loss angle. There may be confusion. There may be confusion. I will explain once more. See how this capacitance arouse, you already know this. I have already explained. This is nothing but the capacitance in between conductor and the outer insulation. There is also a resistance, right? Because this insulating material is itself act as a resistance. So it contains a resistance also. So here I can represent like, a resistor also. So RC in parallel combination. That is why this circuit is equivalent circuit. So of course the total current, the total leakage current through the insulation, that is I, is nothing but IC plus IR. That is a vector addition because capacitor and resistor. So definitely the vector addition will be placed here. So this IC plus IR will be I. That is nothing but IC plus IR. This IR now, it is always in phase with V phase because it's pure resistor, right? Pure resistor. So IR and V phase are in phase quantities, but V phase and IC are, this current will be leading by 90 degree with respect to the voltage in a pure capacity circuit. So we consider it as a pure capacity circuit, right? Because it's a perfect, almost a very good insulator we are using. Very good insulator we are using. So we can consider like similar to the ideal capacitor. That's why the current is leading the voltage V phase by an angle 90 degree. An angle 90 degree. Okay. The angle between I and IC is called the delta. That only you have to note. We don't want to know this, how this equation arises. We don't want to know this. But you have to know. We have to know this much watts, my dear, this much watts. V square omega C delta, this much watt. So we just want to know the term loss angle. Loss angle is nothing but the angle between I and IC. And one more identity you can observe from here also. Sin delta equal to cos phi. That also you have to note from this. Sin delta is equal to cos phi. That means cos phi is nothing but, my dear, adjacent side by hypotenuse. What is this adjacent side by hypotenuse? Let's check this. Cos phi is equal to adjacent side IC. Sorry, cos phi na adjacent side IR. I will write here. I will write here. Cos phi. From that figure, cos phi is what, my dear? Adjacent side by hypotenuse. Adjacent side is nothing but IR. Hypotenuse is nothing but I. Okay. Consider this as a triangle. This as a triangle. No? IR by I. What is sin delta? What is sin delta? Opposite side divided by hypotenuse. That is again same. Opposite side means this side. This side is nothing but, my dear, IR. So again IR by I. From this you can conclude that cos delta equal, sorry, cos phi is equal to sin delta. Right? Cos phi is equal to sin delta. That all the terms which contain the dielectric power law. So in examination point of view, my dears, remember this equation. It's very, very important. And just to know about what is loss angle. Loss angle for, we can say that one more thing. One more thing we can say, my dears, for, okay, one more thing I can say. For ideal insulation, I can say that R equal to what, my dear? Infinity. For ideal insulation, a perfect insulator, that means R will be, R will not be there, no? R will be infinity. If R is not there means, if R is not there means, there is any del, there will not be any resultant, no? this resultant current will be the same capacity current. Why this resultant current I happens? Because of the presence of IR. If there is no such a resistance here, it will be open circuited. The current, whole current will be is equal to IC only. That means this current will be IC only. There will not be any del. So del will be equal to 0. This also may be asked. When this happens for ideal insulation. For ideal insulation, this R will be infinity, so that del will be 0. So that del will be 0. Cos phi is equal to 90 degree happens there, right? Cos phi will be 90 degree happens. 90 degree lead will be happen. Okay, that's all. Cos phi will be not 90 degree, cos phi will be cos 90. 0 degree lead. 0 lead will be happen. Cos phi will be 0 lead will be happen. Is it clear, my dears? Is it clear? Okay, so let's do a. So at that time, what will be the power loss, my dear? What will be the power loss now? So at that time, P loss will be equal to power loss will be equal to 0, because del will be equal to 0. Del will be equal to 0. That's why. Del no. So there will be power loss equal to 0. So a one word question may be asked, also asked like this. For ideal insulator, what will be the dielectric power loss? Dielectric power loss. This is a dielectric power loss. 0. That's all. So for examination point of view, one more, let's discuss one question. It's a beautiful question. Normally asked in the examination. See, power system is a very big subject, my dear. Very big subject. You have to learn very enormous things from here. Enormous things from here. It's not an easy task. It's not an easy subject, and it's not an easy task also. It's much better. Okay, my dears. So let's discuss a question. If voltage is increased by 10%, then dielectric power loss will be dash. Dielectric power loss will be dash. Option 10%, 20% B. Solar increase 10% increase, B 20% increase, C 100% increase, and D 21% increase. So how can we solve this? So this is a question. How can we solve this, my dears? Voltage is increased by 10%. Then what will be the dielectric power loss? So there you can apply the equation. There you can apply the equation, my dears. So what was our equation? We have what, my dears? Dielectric power loss. Dielectric power loss is equal to nothing but V square omega C del. Or I can say that let P1 be the dielectric power loss at particular voltage. Thus I can say that simply PV the dielectric power loss P is proportional to what? V square. I can say it now. So I can say that P1 will be proportional to P1 square. Then what will be P2 if voltage is increased by 10%? So V2 will be nothing but V2 square. So V2 will be nothing but, my dear, what? 10% increased means it is nothing but, my dear, 1.1 V1. Correct, no? Whole square. 10% increased means normally it is V1. It's 10% increase means what? 1 V1, 10% increase means 1.1, correct? 10% increase means what, my dear? 10 V1 by 100 plus V1, correct, na? So it is nothing but what? 1.1 V1, correct? So it will be P2 will be equal to 1.1 V1. So let be equation number 1 and let be equation number 2. So P1 by P2 will be equal to what? V1 square divided by 1.1 square into V1 square. It will be cancel out. It will be equal to 1.1 is nothing but 1.21. 1.1 is square is nothing but 1.21. 11 square is 121. That's all simple. So I can say that P2 will be equal to 1.21 P1. P2 will be 1.21 P1. So change in the dielectric power loss will be equal to P2 minus P1 by P1 into 100. Am I right? P2 minus P1 divided by P1 into 100. Or simply P2 is nothing but 1.21 P1 minus P1 divided by P1 into 100. Which is nothing but, my dear, 0.21 into 100. It is 20% increase. Is it clear? Is it clear, my dears? So that's how you have to solve the problem. Okay? That's how you have to solve the problem. Is it clear? Is there any doubt? You can ask.